Alright, so in this video I'm going to be explaining another important article, and the title is Combinatorial Optimization with Physics-Inspired Graph Neural Networks. This paper in Nature 2022. So combinatorial optimization problems are pervasive across science and industry. We apply a relaxation strategy to the problem Hamiltonian to generate a differentiable loss function, which we train the graph neural network and apply a simple projection to integer variables once the unsupervised training process has completed. We showcase our approach with numerical results for the canonical maximum cut and maximum independent set problem. So nowadays we solve, as I explained in the previous videos, we solve these classical computer science problems like max cut, min cut. We solve them with graph neural networks. Of course, it is still an ongoing progress, but what is important is this matrix Q, and then so our optimization is just X transpose QX, which we call it this QBO performance measure. This QBO performance measure is Hamiltonian, is what we need to do any combinatorial optimization. And X is just a vector of binary variables, and they could be 0 or 1. So it means that there are decision variables. For example, if the edge between two clusters exists or not, given one vertex. Or any other problem like independent sets in classical computer science. And the significance of these QBO problems is further illustrated by close relationship to famous Ising model, which is known to provide mathematical formulations for many NP complete and NP hard problems. So this shows the flow chart illustrating the end-to-end workflow. First, we have this problem set up. Now, as I said, each problem has a different Q. For example, max cut has different matrix. Maximum independent set has a different matrix. And then they give it to GNN for training. Finally, we just project, because finally your decision should be 0 or 1. It couldn't be a soft decision. It should be a hard decision. So for final evaluation, you will see the final results. For example, this is an example of max cut for random 3 regular when we have 100 nodes. So an edge is said to be cut when it connects to vertices of different color. So we update our graph neural networks using this equation if you want to use graph convolutional network. And the last case layer output is used to predict the label. So the relaxation is that we assume that it's a continuous variable, then we solve it, then we project it. Same for any other problems like max cut or maximum independence set, that we have this interesting Hamiltonian. And implementation of that is very simple. We give it to graph convolutional networks, and the cost is this QBO that I said for different Q. So once you know your Q, each Q is a computer science problem like max cut. Another Q is a different problem like min-cut, independent set, covering all the computer science problems.